let's go over another question. Here it asks to find the length of one arch of the cycloid. Now here it asks to find the length of this arch, right? Now in the previous video we computed the area under this curve, but now we are going to find the length of this arch, right? Since it is the cycloid, we know that the parametric representation is this one, and also we saw that it starts at the parameter theta 0 and the endpoint of this one is the parameter 2 pi, and remember the x coordinate is 2 pi r. There is a difference, right? Okay, and I explained all these details in a previous video, right? And in order to apply these values for this equation to compute the length, we just find the derivative of x with respect to theta and derivative of y with respect to theta, and directly plug in those values to this integral result. And after substituting it to this formula, we just have to use the techniques that we did before to evaluate the integral. So to do that, we just expand this term and then we come up to this stage, right? I think I have not written down the square root here. There should be a square root like this. Okay, so then you will get this one. So to solve this, we can use this half angle formula, right? So you can see that you have these sort of relationships, and then the square root of 2 times 1 minus cos theta will be reduced down to 2 times sin theta by 2, and then you can integrate sin theta by 2 like this, and by computing the two limits you can see that the arc length of this single arch is equal to 2 times r, right? Now see, although this is generated by a rolling circle, these results are very much different, right? Kind of strange, because now if we just get the circumference, it will be 2 pi r, right? But this length, now circumference means the length of this circle, right? But this length is 8 times r. These are some interesting results that we can obtain from the cycloid. That's why we specifically discuss about the cycloid. There are some interesting results that we can extract out from the cycloid, although it is generated from a rolling circle, right? And I think this result was observed or kind of proved by a person called Sir Christopher, and I think he was the architect of St. Paul's Cathedral in London, right? So those famous people, those creative people have figured out methods to obtain these results, sometimes maybe even without these integral tools, right? Because with these integral tools it's very easy to come up with those results, but just imagine if you don't have these tools to compute the length, right? It will be very difficult to imagine such a thing, right? So maybe that's why they are considered as great mathematicians, right? Okay, and in the next video we will learn about surface area of a parametric curve.